f dash x equals fx plus integration of 0 to 2 fx dx. And we are also given that f of 0 equals 4 minus e square. This is e square divided by 3. So we have to find out fx, and there is another part, second part, that we have to find out the number of solutions of x plus fx equals 0, right? So if we found out the value of fx or the function fx, then we can easily find out the second part as well, right? So let us try to understand what concept we can apply in this. F dash x equals fx. So by this, you clearly see that this is a differential equation, right? And this part is nothing but some constant, because this is a definite integral. You can take this constant as, let us say, k. To start with, you can take this constant as k. Fine. Now, by taking this constant as k, now we have this differential equation. Take f of x on this side. So let us start with this. So this becomes f dash x minus f of x equals k, right? Now by this particular equation, you can see that either you can write this down as dy by dx minus y equals k, right? You can make this in this standard form, or you would have done many questions that you can multiply both sides by e raised to the power minus x. And why minus x? Because you know that if you multiply by e raised to the power x, then the minus sign will not be coming out. So that's why we are multiplying with e raised to the power minus x. So let's see what happens. So once you multiply, so it becomes e raised to the power minus x f dash x, right, minus e raised to the power minus x f of x equals k times e raised to the power minus x, right? Let us solve this step by step. Now, if you are able to see that if you will be actually integrating this function, right? If you will be integrating this function, so this is a derivative of, you can clearly see that if you take the derivative of this function, let's say d by dx of e raised to the power minus x into fx. Just take the derivative of this function. E raised to the power minus x constant, then derivative of the function, fine. Then e raised to the power minus x ka derivative, f of x will be treated as constant. That is the product rule, right? So this is clearly derivative of this particular function. Now you can write this particular thing as, or you can, if you want to integrate on both sides, after the integration, you will get this particular thing itself, right? So you can say that this is d of e raised to the power minus x into f of x equals and e raised to the power minus x dx, right? You can integrate both sides. So once you integrate, this function will be as it is. So it will become e raised to the power minus x into f of x equals integration of this particular portion, which is minus k times e raised to the power minus x, of course, some constant c, right? So from here, at least you will get the function f of x in terms of k and c. So let us see what other information we can use. And from here, we can choose one more information. That is, if you want to find out the value of k, k is 0 to 2 fx dx, right? This is the value of k. Now, what will happen next is f of 0 is this. So you can apply this particular given thing to find out relation between k and c, or to find out itself k and c, right? So you have two things to do. K is equal to this and f of 0 equals this, right? So now among these two things, if you use these two things, let us see how we can do this. So we can again use, because we know fx, so let us write down fx here. So f of x for us is equal to multiply both sides by e raised to the power minus e raised to the power x, so that it becomes c into e raised to the power x minus k. Now this is a f of x. And you know that k is this. So let's try to find out the value of k. K equals 0 to 2 f of x dx, right? Now f of x is this, c into e raised to the power x minus k dx. Now it is very easy for us to integrate this particular portion. This becomes c into e raised to the power x only minus kx. Now we just have to put up the limits from 0 to 2, right? So this is c into e square minus 2k minus substitute 0, which is c minus 0, right? So this is the value, and of course we can take 2k on this side, so this becomes minus 2k we take on this side, so this is 3k c into e square minus c. So k, now we have got c into e square minus 1 divided by 3, right? So now we have got the value of k. Now we have got the value of k, and of course we know f of 0 is this, right? So use this again. From here we have f of 0 equals c minus k, which is equal to 4 minus e square divided by 3, right? And we already know what is c. So from here we can find out c and k both, right? So let us try to figure out what is the value of k and what is the value of c independently, so that we can find out the value of f of x, right? So let us try to calculate both the things. So here we have c minus k equals this thing. So again, let us try to see which is the relation that we are having. K equals this. So substitute. So this is c minus c by 3 e square minus 1 equals 4 minus e square by 3. So of course we can take the LCM, and this becomes 3c minus c times e square plus c equals 4 minus x, right? Now from this equation it is very clear that if you compare the terms of the e square and e over here, c is equal to 1, and of course when c is 1, 3 plus 1 is 4. So clearly the value of c is equal to 1, right? So when the value of c is equal to 1, you can get the value of k. This is k. So now we have got the value of c as equal to 1. So the corresponding value of k comes out to be e square minus 1 by 3, right? So now this is the function that we are having. We can substitute in this to find out what is the value of f of x, right? So let us try to substitute and get the value of f of x. So f of x from here is c into e raised to the power x. So e raised to the power x will be as it is. So this becomes e raised to the power x minus e square minus 1 divided by 3, right? So this is the function f of x that we were about to find out. And of course, we have the second part, which is x plus f of x equals 0, right? So this is done. This is the value of f of x. Now, there are other parts also. One of the part is the second part, we have x plus f of x equals 0. So we have to find out the number of solutions. And remember, in finding out the number of solutions, do not find out the values of x for which it will satisfy the equation. We don't need that. What actually we need is the intersection points of the two curves fx equals gx, right? The number of points of intersection. For that, we need to draw the graph. So this is a very simple curve, e raised to the power x minus some constant, right? And e square minus 3 by minus 1, this will be by 3. This will be positive, right? So you are subtracting from e raised to the power x. Let us try to draw the curve. Now, what are the curves that we are having? Fx equals gx. So this is f of x equals minus x, right? So we have the situation f of x equals minus x. So we have to draw the graph of f of x, and we have to draw the graph for negative x. That is very easy, very simple graph, right? So e raised to the power x graph, we already know it is this graph lying above the x-axis, but we are subtracting something from this, so it will go below, because at e raised to the power 0 to be 1, right? And this will be 1 minus something. Now let us see if that is lying below 0, so or not. So e raised to this particular thing, this is y equals minus x. This is one graph that we have drawn. Now ultimately, even if the graph of e raised to power x would have been like this, or it would go like this, it does not matter, right? It does not, because it will be cutting it only once. So let's say if it is something like this, so it will be coming and cutting it at exactly 1 point, right? So if it is cutting at exactly 1 point, we can just say that it is having only one solution, because the number of solutions is equal to the number of point of intersection of these two curves, right? So this is your curve f of x. So there is only 1 point of intersection. So since there is 1 point of intersection, so we'll say that it will be having only one solution. So if you were given the options, you could have easily marked the option for f of x as this, and the number of solutions for fx x plus f of x as 1, right?